Hello, welcome to another video. Been a while. I need to work out what I was actually doing. So, I mean, I know I was doing some BitTorrenty things. Do I have anything stashed? No. So I think, I guess we could do maybe this and search for make PRG. And yeah, we'll be doing this, doing handshakes. So yeah, it looks like I am kind of doing that along with a bunch of debug output, but that's all right. Realize I don't need these. It's just checking that it was all working. Um, so I guess if I so the tests are failing, so I wonder if we can do like a little test here. I wonder why it's failing. Like, did I not push it or something? Hard to know. If we do this, like, see, looks good. So, oh no, that's just building. And apparently, a test were as good as like starting the machine. Sometimes that can be a little tricky. Yeah, so we did not do. Got one. So the beauty of, and I realize we should probably make this a little bigger. I realize that we can actually like do that, and it's not quite them. Your so this one. Gosh, I just want to go. It's weird that it highlights it, but like I don't want to get there. I should make a T-Max thing to do that. I made a thing. If I do something like not that, that. What is it? Plus for calculator. Um, well, that's just that key. Oh no, if I do that, yeah. So I made like a little thing to do some math, so I can I don't know do like 21 times 2. What is it? And it will just tell me, and it will put it in my paste buffer. So if I do that, I can see it. Because sometimes like the Vim arithmetic is not super great. Well, it's accurate, but it only really does like doing multiplication sometimes is not as easy as I thought. Right, so what do I want to do? I actually want to now do. No, I think I shouldn't do that. I want to go copy this thing again because it is not at the top of uh, um, my paste buffer, and I don't really want to show all of the paste buffer. So this didn't show anything, and I think that's because the tracker is localhost, so it probably just can't even get to localhost. It's interesting that it just said nothing. Yeah, so 69 is so if we like grep for 69 and user include sys exits. I've been using these sys exits, but the problem is like on Linux, there's a tool for error no, but it will have like it uses different errors, but like there are like a lot of them, and they're not in numerical order. They're in Yeah, so 134 of them. Yeah, it's kind of numeric, but this 95 is just not there, but then it is. I don't know, that's kind of weird. But yeah, there's like a lot, and I've been using the BSD style sysexits, which I don't know, reading up like it seems like people don't really use anyway, but I kind of like it. But the problem is I need to do like a grep to find out what it is. So that is saying that the host is unavailable pretty much. So this makes this a little tricky to debug because it works well. We can't test this on this one, but we could do like uh, well, actually, no, this, yeah, so this is like the same magnet handshake, but it's pointing to there. So I wonder why we couldn't get the pair ID there. I kind of, well, this has the logs. So we can do debug is true. So I don't get it. We like kind of print it out, but then maybe we like do a bad um like we don't close the. Do we have to say goodbye? I don't know. But yeah, I guess what we can do is go in here and do an old true, and uh, then if we do something like code crafters test, this should fire off whatever I have in my path. It's actually kind of cool. It makes like a kind of pseudo git commit out of it. So yeah, this is what's happening. Um, we have a tracker, we have a pair. We do a tracker request here, then we figure out what pair. Then we wrote, so we've written a bunch of things. We get a handshake. So then we get the pair ID, we get a bunch of stuff. So, are we not replying to this extension handshake? I feel like this is where we're at. So I think I have actually just. So I want to close the logs. I've finished the last one. I think, yeah, I finished this, and I must have just been on this. Well, that's good. It's what I get for not doing this in a while. So, what do we have to do? So we have to just say what extensions we support. Yeah, that's right. So I was reading up on this extension handshake. This rings a bell. So we basically have to send like a dictionary with all the extensions that we have, and so we could have others. And this is basically tying this to an ID. This 16 is arbitrary, and what that will do is that's kind of like a bad highlight font. I don't know. Yeah, so this metadata is now ID 16, and basically you will do this handshake. So have they sent us one? They have sent us one, and we just haven't replied to it. So I guess they're going to send us the dictionary that will have something like this, and we basically have to store somewhere that the metadata is 16. Um, and we go and do this. So this is what's happening. We do this. So if in that bit field we have that extension, we then do this other handshake. Um, cool. So we just pick an ID. So I guess right. Can't be zero. Easy. So I've been thinking about this old program, um, and I have been wondering because like there's been like a lot of double ups, duplications of code and whatnot. And what I kind of want to do is, which will in the long run help out with some of the um, uh, extensions. No, I think they call them challenges. To like even the base one is like an optional challenge, and it's basically have the idea of multiple multitasking and scheduling jobs and whatnot. And I'm wondering whether this is what I need to do and kind of construct a notion of a pair structure, which is kind of passed around and it may appear in the job structure. So uh, yeah, I guess this is what I want to do. So that's not what I wanted to do, but that's all right. It's kind of a I don't know what key I used to open it actually. I would have done something like that. So yeah, cool. I've done it. The surfing keys thing, it's kind of cool. So like I can just copy things there. I can go to any of these links. I can like copy. Oh no, I can copy any of these links. Weirdly, it's a different set of links. I think I know why. It's because this isn't actually a link. It's just expanding that. Anyway, enough rambling. So what I think I want to do is actually get rid of this idea of uh, I kind of want to refactor some stuff out, which is potentially not really looking towards this, but it will make this next challenge quite a lot easier, I think, because the idea is we'll have like we're in a C file, but whatevs. Um, So we basically will have like a list of jobs, and I don't know that's our jobs, and each time we might have some workers, and each time a worker becomes free, so like it will have like a state of like potentially just free and busy. Maybe done actually. So it kind of transitions into that, but maybe not. Um, and then you can basically have a worker per thread, and that's the idea. And then each time a worker becomes free, which is after it finishes the job, or on startup, they're all free, I guess. And when that happens, it can come along and take one of these jobs and start working on it. And these jobs, they could be something like you could have a so pretty much everything that we've done. So we could have like a tracker request, but we could really have it like a get pair list, which would make a tracker request. But we could tie whatever the tracker request cache the body somehow. Like it's just a bit encoded dictionary. We just need to be careful not to free the memory that was pointing to it or make a copy. But we won't want to pass around all these structures like as values. They'll need to be pointers in memory. So what other jobs might there be? There might be a connect to pair, and that could simply be just getting the not the TLS. That could simply just be returns NFT. I mean, we already have the function, so like these jobs will kind of tie into some of the functions that we already have, but it will just kind of make it easier because now we could have like a handshake here, and like potentially this doesn't return FD. It could return a pair structure, but then that could get created as whatever gets passed. And so, like, I think each of these jobs would also need to have, like, so it'll need to have a type. It will probably need to have some data. Which will be a lovely void star, most likely, which based on the type you then cast into whatever type it should be based on that type. It's where things get tricky with memory corruption, because if that type gets corrupted, you might then take the data and use it as a different thing that it actually is. C isn't like the safest language, but it is what it is. As long as you know the hurdles, you can get around it. And I think this would probably also need to have like a callback, and that callback will probably just take like a reference to the job, maybe, and that can just get out the data. I think that is probably what that does. And yeah, then after a handshake pair, you could potentially do like handshake extensions. And so like that would kind of mean that you have just these the connect pair, like I think you need it, the sockets don't kind of carry over on threads, so that might need to be something a little different, or like just have one pair per thread. So like a pair might have maybe thread ID, and like all of this, I also need to take into account locking and whatnot to make sure that things don't get done at the same time. Like, for example, adding something to the worker list or removing something from the worker list. That is something that will be done by multiple threads at the same time. So you need to kind of have a lock around that so only one thread can access and modify that. So, what do I want to do? It's like a big refactor. It's something that I probably should have had from the get go, but I think what I probably want to start doing is maybe just make some things. So, what will the job have? It will have a job type, and this will be a type. So this, I think, needs to be like that now, just to make the syntax highlighting. And what's that job type gonna be? That's gonna be an enum. Something like that. Cool. And what is this going to have? The type is um, maybe just none to start with. And I'll let, I think it's that. I'll let the compiler tell me anyway. Gosh, I'm getting like something in my. Ooh. Right. So I also reckoned it needed a void star data, and I also reckoned it needed, gosh, it's going to be void. Um, then it's something like this for the name. Oh gosh, I don't think I recall. Um, I mean, I can probably just check. So if we do like a quick there, maybe even this and like I don't know what will have it. Users. Um, well, in fact, I can do a cheeky some ways to do it with just what you have. You can do something like you can probably just do something like if printf, and the compiler will probably complain if I do something like this. It'll be like, what do you mean by that? Me. So something like this. Yeah, so oh, that's all right. I'm quite happy with it because it'll be that. So yeah, it's helpfully given me what it expects. Go there. What it expects for a function declaration. So if we get rid of that and come back here and no, not that. So that's kind of what it wants. So we do want something like void. I think this needs to be just there. Cool. So we do want something like this, and so we gave a pointer to main, so I think the star is optional. So I think I was quite correct in doing something like this. It's a bit cursed looking in C, but you can, like some people just type def it. So what's this going to take? It probably wants to take a struct job, but probably and like you can kind of name it, but you don't need to. But I think that is probably what I want. And because I'm referencing the job within the declaration, I need to kind of do this, call it a struct job, but I'll call it just a job everywhere else. What else did I want from this job? So that's probably all I need. So what's an example? We also need kind of a, yeah, I think what I'll do for this cool episode, what I want to do is actually do or right, something happened there. Should still be working. So maybe I'll go to here, and I want to do this, and what is happening is that should do the trick, and if I do something like that, yeah, cool, that does the trick. What the problem was is I've got some I don't know, screensavers that kick in and after you uh, ramble on for a while, I guess. Um, but yeah, they look pretty cool. I don't know. I got bored on the weekend, and well, that one doesn't look cool. Can't have a choice of that. But yeah, like that. But the problem was that I could not see the output of my FFmpeg, which is what I use to do it. I don't know. It's just a collection of cool things. My favoriteest one is this. We've got like a cool as aquarium just in your shower. It's really CPU intensive though. It will burn up your laptop. Anyway, back to this. I don't even know if the audio is working. I hope it is. Hope the video is working. My setup just doesn't let me know. I should just use OBS, but I don't know. You can actually just do a lot with FFmpeg and using posts and pulse effects and a couple of loopbacks, and then you can hear audio as you're recording it. Anywho, so I want like a type def struct. So this is going to be a job list. So this is going to need a key. So I think. So, oh no, I'm in the wrong mode. Apologies. Go this way twice. So if we, I don't know, look up that, can we look up that? Can we look up that? Yeah, so P threads, POSIX threads. So it'll work on POSIX systems, I guess. Won't be Windows friendly after this, I guess. But can probably do some defined tricks to get around that. So this does like a lot of things, and what I want to know is like, is there a lot? We can do a lock F. So what does lock F do? Gosh, lock F. Nah, I don't think that's what I want. I want, what else do you call them? Like conditional, like conditional, what do you call them? I could just use the old Google to look it up. Semaphore, oh yeah, Simop, Simop, all right, System D stuff, and this is like 2 as well, so it's like kernel level. There was a different thing we can do, like atomic, atomic. I don't know. This is where it is. break out the old Google and maybe go like this and C thread like what do I want to call it? uh, like log. Uh, like mutex. Yeah, this is probably what I want, and this probably mutex lock. Cool. All I want is just a lock. So this probably would don't have that, but how did searching for lock not find lock? I it baffles me, man pages, but oh now it does. I don't know. Maybe I just didn't go long enough. Right, so I do want something like a p thread mutex lock, and we probably have to do a thing. So p threads mutex lock. And what can you tell me? You can't tell me anything of that because you don't have. P. Oh no, I'm struggling today. P thread mutex lock. P thread mutex lock, which it reckons it should have a 3-man page, but it's just like not finding it. Bottom things, yeah. P thread mutex. We just don't have that man page. We could do like a spin lock. It's like a bit grosser. So like a spin lock is like a busy one. Yeah, so it just spins. Oh, yeah. So we just have to like create a thing, right? What I want to do is just know what I wanted to add here. So I need a. Where's this mutex come from? P thread mutex T. It had been a long time since I've been doing synchronization in P. Not in P and C. But I think this is reasonable. So, what I kind of want to do, so the job list has that, but it should surely also have size T, maybe a capacity. Probably also wants to have a bunch of jobs, which maybe I'll call data, and this can also have a size. Cool. So this is now just an array list, which, yeah, like we could. Well, it doesn't actually have to be an array list. It can be anything we want, just because we haven't actually defined how what methods are going to be operated on this. So a naive approach would just be to make this an array list, and the data points to an array, and then it would be data index that. But like other approaches, you could go like more priority queues, like first in, first out, stuff like that. Now, because jobs are kind of going to be coming in and out, it potentially makes more sense to have it like a, yeah, have it more like a stack. So if we were to do a stack, I guess like we have to kind of have a few functions. So we would probably want to have like just a job list uh, list, and we would probably also want to take a job as a pointer. So we would want to have something like this. We would probably also want to have a job next maybe, um, and that would also be returning us a pointer to that. And we would want a job list free at the end. So do we have to like initialize the mutex? So we can probably do something like this. Um, is that, no, I won't like me doing that job list. That is what I want. Do that. Cool. Um, cool. Now I wonder whether this will like things doing. We're not allowed. A, are we not? To C just not. C pull back struct. Like yeah, sure, that's how you do it. So yeah, we have a some type of thing, and we do that, and the yeah, I think this is legit. So this is like how you type def it. So maybe I need to actually do something like apologies, this is not going as smoothly as I want. So something like this, but this is maybe a job callback type, and this is going to be now see this is can we just do something like that? Let's call it data. And like, do we need we can really just call it like that. Like, would that complain? Yeah, so now instead of that, we can do a job at CB, CB T, and this is going to be called callback. And instead of that, right, so it like that. Now, I think that is because we didn't have the pointer there, which would make it like it looks a bit cursed, but once you know what it is. So you do need that star symbol to say that. I suppose because you're not passing it the value of the function, you are actually always passing it the pointer to the function. Um, Right, so we don't know this, and that's probably because we need to um, like, I don't know, like what do you have to include? This had like right, it was just P3. I probably could have worked that out. And if we do something like that, we can probably keep that for now. Right, so we can't do initialization there, but we have to just remember to do that whenever. Um, that's frustrating. Because like I don't know now, like when we create the list, we need to make sure that we initialize the lot. Um, so I guess what I want to do is like maybe just uh, we kind of want to have a job event, uh, something like this. We don't need to actually pass in anything. This is essentially just going to go forever. So actually no, we do need to add stuff to the like the initial jobs. How did we do this? No, I think that is right. So we basically have like a list of jobs, and this will equal to lot equal. Do we have this available? Thank you very much. And I might just make that a little darker. And maybe do something like that. And so now we can just have, well, jobs dot uh, size is greater than 0, which is a conundrum because we haven't actually added any jobs here. So I wonder if we just give it an initial job from main, and that can be the job that we do. I think yeah, I'm not too sure what I am thinking about the job type. Because then, yeah, I also, start job. If start job equal null, we can just return. So we do need a starting job. So what I'm thinking is instead of the type, we actually have like a function, and the function is that's going to take the data. I guess I'm just not really seeing, and we can probably go through jobs dot data if job data, we shall free it. And we could probably go job add, and now we can take a pointer to our jobs, and we can add our start job. Yeah, I guess because like a thread is going to be if this is potentially the wrong approach. So if it's like just one thread, I think this would probably make sense that we have just an event a loop that pretty much goes round and round, picking up jobs, delivering them. But the problem is that we are going to do this multi-threaded, which kind of means that we need to make this like a job list. I guess we haven't defined what the work is, so maybe I can see how a worker kind of fits into all of this. Yeah, this was something I was debating doing off screen, as they say, and potentially I might, but sometimes you have to write really bad code first to work out what the code is meant to look like. So, we're going to have jobs, we're going to have workers, and the workers are going to check the list. So, this job list needs to be fairly central. And the workers need a, in essence, do something like this, but maybe. And did I change that? Yeah, so I got rid of the job type thing. Potentially, this isn't quite what I want. We'll go back to here, just in case. Yeah. Because really, like each thread will have a pair, I guess, attached to it. So, like, this will have like I'll have something like dev struct of a thing, which is going to be a pair, and in the pair we are going to have like a way to talk to it, and we're going to have probably a state, like whether we're in fact like this. If we tab through these, not that one, yeah, this one. So appear can be choked or and not interested. So I think I've lost some. Sorry about the white. So we just have choked or not and interested or not, and we both start out as like, oh, it's kind of annoying because like so far I've been able to get by with like if we wanted to define a pair, we can just go pair p equals and I've been doing this sort of thing, which basically means that everything inside is null, and ideally it's in a working state. But if I do something like we've got a ball, uh, and this is going to be choked, and we're also going to have interested. Now the problem is that in the C, a ball is really just an int, and really like a zero is false, and anything else is uh, anything else is true. Um, 2, 6, 7, that number without the that. It's pretty nuts. But the problem there is that means that we're defaulting to false, which is not how the spec kind of says that we're done. So maybe I will just do some Englishing and say we're unchoked and uninterested. And so then when we get to the pair, we can create it like this, and it should, the file descriptor will point to standard out, I guess, by default, which will cause issues, but that's something that you could probably check, whether the file descriptor is 0 or not. There's no real way around that. But what you can do is actually just set just the file descriptor to so like connect here or something, and then that would, whatever that takes, that would then pass in that file descriptor just for that, and everything else will be 0, which would mean that it'll be unchoked. It will mean it is not unchoked and not uninterested, so it'll be choked and not interested. Or we want to start not uninterested. Hoi, gosh. So that would mean that if we wanted to be interested, that would be 0, which would mean that we are interested. Let's go to there. So here, if it's 0, that means we're not interested. Cool. But this unchoked, I think, does need to be the because if we're 0, that means that we're choked, and we do start out as choked. Cool. Let's put that back on that page, just a bit more soothing to the eye. My other screen is like quite bright. I mean, it is quite bright. I actually apologize. I don't know what the camera looks like at the moment, but it might look like real white over there. I couldn't quite get that working. I could do like a hand up, but that could be frightening. Like cover the lens and not. Cool. So we're gonna have a pair, and this pair also probably wants to have like a list of extensions. So like when we get stuff, in fact, like I mean we've actually got this code already. Well, we don't actually. We've got a pair style H, which I was thinking of doing as a standard single file header type thing, but I think it is potentially growing out of it, because we're just getting a bunch of things. So what do we get in handshake pair? So the pair ID we could probably keep. So we need a pair ID for like the other end, and we should get like the extensions. Where am I looking? This is just like getting pairs. Yeah, so connect pair, we just connect to a pair. The handshake pair, that's what I want. All right, so like this sock would just be part of that pair structure, and so this response, I guess, is also probably we want to get stored in the handshake. Um, so that means that things that call this, uh, if we do something like this handshake, yeah, things that call this, there's like another thing that I know that can do it. If we do this, we get a response, and so we kind of track the response here to get the pair ID. So the response we kind of need to get some stuff out of, and like this would kind of get refactored. So instead of doing this, it would just be like, hey, what is your pair ID, and that's just there. I also want to look here. What do you do with the pair ID? You kind of do the same thing. So like that's just two things doing the same thing. One's doing a handshake file, one's doing a magnet handshake. Yeah, so like these two things, they do similar things. Um, and we also do it in pieces. So we get a response. What do we do with that response? Do we use you? Yeah, so we don't even use the response at this point. When we're doing like actual downloading and download piece from file, and what was this one? Download from file. So when we're actually downloading, we just don't even care about the response, but we give it the memory, which is interesting. So I think what I want is in at job.c. It's not really the place for the job, but we can probably have something like this. And that means that we can see in the handshake uh, all the things that kind of are. But like potentially a better way to do it would be to not do that. Just get out the bits that are needed because then it'll be a bit less space. But like I don't know, memory is fairly cheap, and we're not going to be passing like values of it. So this handshake size should probably get do that first, and then do that, and take me there, and oh yeah, you had it there. We could probably take this. App. Yeah, no, the app job that's where we're putting it now. And we could probably do something like this just to keep it handy. So we could also do char uh, care ID, and this can just be yeah, ID size, potentially like +1, and do that. And then when we process the handcake, we not the handcake, we just do copies into that because we're already doing a mem copy of the entire handshake. If I'm not mistaken. Response. Where do we do a thing? We did it here. No, I want to look here. So the response, we read into that the entire thing. So yeah, the data is just already there. So if we go back to job.c, I think this is potentially useful, and memory is reasonably cheap. But it's kind of like copying. So like of 68, it's copying 28 things, and I think what I'm going to do is do something like this, and it's been. No, this is more like reserved. And this will be reserved. I did the sign. I like saw my finger. What else did we get out of the handshakes? So it was only really in here, and response was only really used to get the peer ID. So take me here, yeah. So I think in this, we probably wouldn't want to have this in the thing. So we'd read to somewhere else, and then we'll just do a copy into these relevant places, which would start up 0. And so that last byte should be 0 once we copy in just that size. So what do I want to do here? And I guess the peer needs to kind of know when it goes in and out of things, and I guess that will happen when I'm just wondering. Gosh, it's just it's a video of me wondering. I don't know. I've written some code, but not that much. 50 lines. How to write 50 lines. It sometimes is like that. So I want. I'm kind of trying to do two things at once. Refactor pair and to have just this kind of structure, and also having a job queue. Because I think each pair should have the job list. Nah, that doesn't quite make sense. Because like you want one job to download piece, download piece, download piece. And I guess yeah, the output of well, I guess like because of that the callback kind of needs to take the job list. as well. Which isn't defined. Ah, that's annoying. But we can do something like this. C is cursed. No, just add that. And then here, no, don't do that. Here we can do job list. List. Because once we finish the job, we do the callback, then that callback might be like, well, because you've done that, you can now do this. And that'll add something back to the job list. An example is like, say you have a command line option to download a file. You might have a full job that's like, right, I need to download a file, and then I need to do this, then I need to do this. So like the callback from the first thing will kind of come to the point where like downloading a file, I guess, which we've done in the whole process. Like, boom, download a file, and like this kind of thing is you would. There was a weird echo. Like you would kind of have to parse the file or the magnet, whichever you're doing, and those two can be like kind of independent jobs. And then once you've finished parsing a torrent file or a magnet file, just download it. So I guess like you would also kind of um, like kind of have a type F struct, and this is going to be like a file, etc. Maybe we can call it a torrent file, and that torrent file will have kind of all the things that it has in it, and it might have in it not that, like here, and we'll just call it pairs, and size t PLN. So this will like kind of be dynamically made after it does a request. And what it could kind of base that off is once a job comes back. So the job might be as simple as like make a HTTP request. And once that job completes by the response coming back, you can then check the torrent file. Oh, pairs isn't set. I will set it from whatever the response of that torrent request was. And then you would then populate these pairs into. Why is my mouse not doing a thing? I was kind of in visual mode. And yeah, so once we do that, we'll parse the torrent file. We would kind of break it into pieces, and each of the pieces would be kind of stored here, which is something we probably have somewhere else, which will kind of just get shoved into this structure, which will then kind of pass everything around by just references. The memory will be created somewhere. Like each of these will create some memory, and then when we free up the torrent file, we'll free that thing. So what else would we have to do? And the handshake again, like we can kind of see, uh, is peer ID set at all? Nope. Let's go do a handshake, and then that will populate the reserved, the peer ID and the reserved, and then once it does that, it can then say, well, does reserved have anything else? Otherwise, it can set this unchoked and interested. Though that comes from when you get the Bitfield response. Yeah, so like in the pair handshake, no, it's not even the handshake. I will do this. we get a bit field response, and that bit field kind of tells us stuff. Yeah, here we get an interested. So once we get the interested, we can then set ourselves as being interested. That kind of just means we've sent a thing. Um, and then once we can unchoke, we can then set the unchoke. And there's things, I think it was third in, where we can like get cancel, I think. Yeah, we can say we're not interested after a while and we can get choked. So like we don't actually respond to those, but they are something that we should potentially. So yeah, I'm kind of wanting to come back here, but then do this. Have like a job structure that can kind of do that, but it's all based around this thing. Like, what I don't know is whether sockets that I get from a peer handshake, if we just do a quick save there. So we get a socket from this, which is a legitimate, just like this is, yeah, socket. We get a socket. Now, I wonder whether this tells me some stuff about socket, whether like thread. No, but what if we come over here and like maybe search thread socket? Because I wonder whether you can actually have like multiple like threads having the same socket, if that kind of makes sense. Um, uh, cool. That's like we don't need to call that. It's cool. That's fine. This doesn't really tell me anything. Didn't really read the question. Um, this has stuff in it. Cool. So they've got some sockets. They are like legit just global things. And then like do some threads. Um, it looks like you do have to do a bind on receiver, and that's doing the listen stuff. We're more doing the sender, so we do a connect. So I think, yeah, the really we should do a quick test to like maybe work out how to do it. Let's get rid of some stuff here. So we need STB int for um, the int types include and std bool or bool. By the int types, I mean there was a we also needed something for size t, I think. I don't even have it there. You wouldn't take, but I changed it to be charged because, wow, in fact, like, let's make it a unit 8t and it can be printed as a char if need be. Cool. So I does this multi uh, is this valid over multiple threads? Otherwise, like potentially, like I don't know. I feel like each thread is a pair, but like we can open up multiple sockets to the same pair, um, if we want, for example, which I think it kind of suggested that even when we're downloading just a single piece, we can have like 5 at once. Yes, take me back. Gosh, tooth's hurting a little. It feels like there's something stuck to it. There is not something stuck to it. I know there's not. I wouldn't say hurt. More what's hurting is my tongue now that it's been looking at for like ages and it may have ulcers and whatnot. Annoying. That's just what I get. Where was I with these thoughts? So yeah, so that was for downloading just one single piece, but a piece can be many blocks. Um, yeah, so each block. Like yeah, we would want all these torrent files to be split up into things, and potentially I should be wary about sticking with just torrent file because there might be multiple, but the pairs are associated with. Well, like torrent file can just be this. Cool. Where do I want to go? I just want to do a quick test, really. That's what I wanted to do. So I was saying this was, we can just take the whole thing and do that. We don't like that because it should be that. Cool. That can be that. Yes, I also did need that for free. And Malik soon to come. Right, so now that's doing like a thing. But if we go to like maybe how do we connect to we'll do a handshake here. Gosh, there's a lot of I kind of want to get a random pair and do a handshake with a thing, but I think at this point, whatever function we're in, hopefully it's the magnet one. Yeah, it is. At this point here, after we've worked out that it is a thing. No, I think I want to do a different test. Maybe something like this and just call job test. And that is going to call a thing. Maybe we can even declare it because C likes that. And in a job, we will have a such a thing which is void job test. And that will be that, and get rid of, don't get rid of, do that. Cool. So what the job test is going to do is basically just do like start me a thing. We'll have a thread. Well, like, do we have more than one thread? I want more than one thread. Oh gosh, do I have to have a? Oh, we can have some shared memory. Gosh, is that like something I need? Um, I feel like I do need shared memory for all of this stuff I'm doing, and then like all of that will kind of just be part of this P, which is I don't know. What's this one show me? I kind of just want to see. Cool. We can do this. What I want to do is basically see if I can get two things and maybe have a sock, which will be, we can call it connect pair, and it will just be local host and this required a port, didn't it? And maybe I'll go 1, 2, 3, 4. And that will be a thing that I will be running here. Um, and maybe even do an advanced feed for thing. So if we do this, we should probably also do a close on the socket. So if we did this, right, it got on a thing, right? So I kind of want to here, and maybe I could even just make it an H, just to make the compiler a bit happy, and then what do you need now? This needs to be in, and we can probably change 0. In fact, maybe we can return 64. I think that is that, and we can probably just have it 64. And if we do that, correct for I kind of want to make it soft, and search that end user includes exits. 70 is what I want. I was too low. Cool. So if we do this and maybe make this like a lot smaller. So if we do this, that should be right, and it should just cool. We connected to a thing. Now I kind of want to make a thing that takes a thing. So I guess we could probably make this like out here, and what do we want to do? We probably want to uh, we'll just call it test. Do these computes need to returns a pointer? All right. We'll call it text. So we need a pointer, and it takes a void star data. And I guess we could probably get this and come here. So this is P TRD. I would have just called it like, really, this is I don't know, P1, P2, something like that. Except I've lost a this I actually want to be up here. That's what I've lost. and do something like that. And then this is p thread TID has itself. Yeah, it knows some things. Cool. And we get this out. I guess we can say this is thread this and we and we can probably just pass this as an int. I think that's what I want. And apologies for the sudden reduction in size. That might have been what it was. Right, so shall we see if this simple test works? We haven't actually hooked up the we want this one. Yeah, so we want to do a thread create create joinable. I don't know. P1, and this is going to have null, and we just call it stack length and null, and we can do the same for that, and then we can do this p thread join, and that's with just two eyes. Yeah, not bad. I should really like disable that when I'm in Vim because I don't know. I'd almost wow, maybe it could become handy then. I don't know. Cool. So I think that is kind of that, and it should just kind of print out to a thing. Can I do like minus W? How do I like uh, uh minus W? I thought there was like a flag to just keep remembering me. Maybe if we do this. Okay. But that's when it's completed. I kind of just skipped over something. Maybe I just want to try that. Minus, got what it is, but I'll go back up. Yeah, what was it? Minus K for keep going. Cool. And then there we can kind of do that. Right, so it is hanging somewhere. It didn't. Well, I guess I can try do some stuff. Oh, like we could even like do this. So it didn't do anything down here. This is giving some warnings that I should potentially deal with. Yeah, that's probably all I need, isn't it? Find the B. I know. Was that all the warnings? No, you also have a thing. We don't need data. That'll just be null, but that's all right. And implicit, that's all right. P thread join. We golly, what's this trying to tell me? Yeah, this is trying to tell me that this is the, and it expected just that. So I guess this and that. And that's probably why I was crashing. Yeah, cool. So here we have that, and like that showed promise. So all I kind of wanted to see was whether I could write from both threads to the same socket, I guess. And I guess this would also allow me to kind of read from the socket. But like, what would it read? I guess it's like kind of in contention, and like it is deeper into E thread. So thread safety. I think that means it's all good to just kind of use. But like when I'm doing something like read, cool. So it should just be atomic. Right, so that's probably all right because it's like more of a socket, not a that. Cool. So that kind of tells me that sockets can be multi-threaded. So that means that I kind of like, yeah, let's close that because that's kind of taking up a bunch of stuff. We'll keep this in just so we can kind of see. But if we head back up here, what is up here? Just a quick thought. Um, gosh, what a photo. Right, so pairs can be multi-threaded. That's kind of a thing that I didn't know, but I needed to know. So once we pass a file, we kind of need to have a way of just getting a thing. So I guess here we would have a job list. And we can call it jobs. And this is kind of where we have to kind of be a little tricky. So here, what do we want to do? If that was 0 to start with, like I kind of want to, as a first step, get a job for just connecting a pair. I think that is probably what I want. And the so yeah, I suppose this job type I do kind of I don't know, because the function I'm going to be calling, yeah, I got rid of it, so let's get rid of it. It kind of makes matters a bit more confusing later on when you're. This way, I kind of define all where it is all at once. So I guess we are not going to have this. This is just going to have a job list. And So this we can probably come to there. So we need to kind of initialize that lock. Haven't worked out what I need the lock for yet, but potentially adding to the list itself. Which, yeah, I have defined stuff, but I haven't actually kind of done it. So maybe we can do this and define job add. So what would happen on job add? We first need to, now did these like initialize the, we do need to initialize that mutex, and the mutex is a global thing, but we store that in mutex. Yeah, so we just store the lock, but we need to initialize that lock there, and that is probably best done here. Jobs.lock, something like that. Does this mutex actually? So this doesn't have this pthread mutex initializer. Does that do it automatically for me? Like, do you have a man page? No. Do you have a man page? No. I wonder why I don't have man pages for a bunch of things. But yeah, if I look up, let's go over here and find that P and maybe get that and then do a wee search on this. So what does this say? This is exactly my question. That's like old POSIX. I feel like I'm well, like I suppose it doesn't hurt to be what's this book? Some random book. Cool. I love like academia. It's usually just the lecturers just write books and show their books out to the students. It's weird. Why can't I get a different book? I feel like doing it the dynamic way is probably the like maybe safer way. Maybe I want that to be there. Let's get rid of some things. Because that way I can have something like this, and then just on the next line we can do that. Cool. So what do we do with that? Do you have any man pages for me? No, but like, does the internet have man pages for me? Yes. Why don't I? Cool. So this, what is that second thing? We init with a attribute. Right, default is used. That's probably all I need. Cool. So once we get a mutex, I probably just want to make a new job. And this is start job, we'll call it a thing. And we can probably here maybe work out what I need to have in it. No, come back here and maybe you take me back there. Cool. So in here, I have a func which needs to go to something, and I have a data which needs to go to something, and I need a call back which also needs to go to something. And if I don't like say what they are, they will be just zero, so I can just delete them. So what do I want as my starting function, I guess? Potentially we can have it as like connect pair. Um, we could have it like something like this, but then the callback will not really have taken into account the like I kind of have a pair here, which will be 0. Um, I maybe I want to quick start this. If we get pairs from file, that's like the thing. Is it not? No, but I can probably go to. Can we update them? That's well, cool. So once we get this, we kind of just. I just want to get a tracker response from Dix. Can we just like find a random pair? Yeah, I kind of want to like maybe I can just yeah. Our first job will probably be get pairs. And maybe we can preface it with that. And so this will probably need to take in a job as a pointer job, and this didn't return anything, so we should put a void because we're not like 1980s C. We get some curse stuff there. So I guess that means that what do we want to pass as our data to our first one is get his job. It's an I don't know. I feel like I already kind of I just need to pass in the pair, which this function it will take the job. So the job dot data will be the pair that we're trying to look at. So something like that, and that means we'll probably need to pass it as that, cast it. Right, so what do we want to call back once we're done with the start job? We probably want to go on to the next one. and like download here, download file. Like maybe I'll just like get a download file job, but kind of interesting. I feel like the callback potentially is not needed, and like I wonder if it's ever needed. So we've got those. We've got our little start job. What we can do is, I assume we can use the lock from the thread that we're in, that we will also create some to wait on a thing. So that's going to be our first job, and we probably want to job list job add, yeah, job add, and this will take in the jobs, and it will also take in a pointer to our start job, and so that's going to become like first on the. That's what I was thinking before. First in our list, which is just an array list, but well, it's not a list. I haven't actually defined what job add was. Which I guess that is what's happening here, which dangerously has nothing in it, and it's a void function, but it should still give me a warning about you're not using this list, buddy. But yeah. I am wondering. I am wondering. Like basically this needs to be a stack of some description, so I guess first we can probably test if list or job, list equal null or job equal null. We can just return, like, who cares about that, can't do much. So then we probably need to see if a list size, we're going to be adding one to it, and if that is greater than equal to list capacity, we need to basically make this bigger. So what's an easy way to do a stack? Say we have like a list of things. We can say like that, and if we just add them in that order, we can just take them off in that order, and that's kind of as easy as a list size minus minus, and yeah. So, but if this is the case, we need to uh, do some reallocating. Now, did realloc move the memory? Well, did realloc work on nothing? Um, right, so pointer is now equivalent to malloc size. I would like to check that, but otherwise we can do list capacity times 2, but this won't work the first time. So I wonder, I've done this before in this project. Realloc. We do a new capacity, which is so we add in the 1, then do the times 2. Which has like the weird thing that to start with, this will be a one element thing. So potentially it is better to, if list capacity equal to 0, we, well, actually no, I'll just, it's kind of like, it grows funny to start with. So if we do it like this, it will start off at 0, and then it will go to 1 because that will be 0 plus 1 is 1 times 2, sorry, so it will be 2, and then it will be 3 times 2, so it'll be 6, then it'll be 7 times 2, 14. So it like kind of goes in like this kind of interesting pattern. But it does kind of grow up to a reasonable size kind of quickly-ish. But it does kind of make these two smaller allocations that are kind of pointless and kind of expensive. Like Malik is not the quickest thing, but this will only happen at startup though, which might be worth the thing. But what I think I kind of want to do, because it's following that kind of pattern, we could probably just say, give me 14 things. But that probably isn't. Can we do reallocate array? Is that what we want? Reallocate array. And then that will take in the pointer, the size, and the thing. And this also needs to actually take in the thing. So the size of number of members and then the size. Because I was actually forgetting that these data is actually going to be the size of job because it is typed as job. So we want to make sure that it is that. That's all looking good. Cool. So once we do that, we'll just keep that. And so at this point here, because we're like adding something to it, we can go list data, list size plus plus equals the job that we already have. Now, all of this, we need to make sure we hold the lock. So what we do is pthread mutex. I love how I have all the definitions in a header file, but there's no manual entry. I don't know why, but so what do you take? Why do you like link to the thing that I want? No, like how do this one. Cool. So the try lock is potentially something we would do, but I think we just want a lock, which it will block until it becomes available, and then it will be ours. So this is what should happen at the start. So this would be list lock, and then at the end we want to unlock the old lock. I'm just wondering. Yeah, we do need to have a pointer to it. Where I go here. So at this point here, we are like adding a thing, and I believe that's kind of adding. It looks pretty much the same as a linked list. Not a linked list. Gosh, no. It, very similar to we can't do that. So we don't want a. We want a array of job pointers, so it's all going to be pointer based. Right, and then this function here, So, I guess in the event loop, which I guess we can do here, this will be run on every thread, and the this will be like kind of what's being started down here. So maybe this would be job event loop. I don't know if this is how you're meant to do it, but it's the way I'm doing it. The way I'm doing it. So once we do this, we just kind of want to get the next job. Job equals job next, and pass in the jobs, and maybe I will actually get rid of that and then put it in there and do something like that. I think I'm allowed to do that and see. And like at this point here, we have existed there. Now, because we're doing all this jobs list here, we probably want to do this jobs data, something like that. And potentially the jobs data probably want to go through and like delete everything. But the jobs might be quite inferior. Right, so we have a get pairs job, and then that should have a pair. And so, really, just one thing will connect to this. So, I guess if we find this, and we can come here. And here we can probably job equals, maybe I'll just, it's not really printing that. I can, well, actually, I can just have it as a percent. I think I want 0p or 0xp. No, xp. Nah. I can't recall if it does that for me, but yeah, maybe we can just have something like this. And this should just kind of, it'll hang, but it will only have one job coming out of it. It won't even compile. Right, I think we can do that if we do that. No, we can't do that. Can we do something like for this and then I don't know, it's the age-old thing where and that middle one I actually just want to test whether it's not equal to gosh, where's my not? Not equal to no. So we do that. Doesn't like that. Undefined reference to job next. Right, so we haven't actually written that job next. That's all good. So job next. Right, so this I kind of want to do an interesting thing. I kind of want to block on this, so it will always return a job. And if there are no jobs, then it will bail out. So, first thing, it needs to check if things are there. And if list size. Sorry, I forgot what I was. I don't know. If list.size is equal to uh, 0, we kind of want to do like wait, do we have a I don't know, this is failing me, but e thread can on wait, I think it is. Yeah, con wait. Block on a condition variable. So pretty much do you have like an example? Of course you don't. Cool. So we do this. It does like not even. That's like I don't know. Some man pages are like terrible. I think this is what I want though. But I want an example. Gosh, from IBM.com. They'll know this stuff. So it's just the man page. Yeah, usage notes, cool. So we have a mutex, that's cool. Then we also have to initialize this condition. And I think this condition I want is each thread. I assume this is cond t. Get me out of there. Cond t. So this is going to be empty, maybe. Wow. We do that, the condition is just that. So we just signal the condition. And then in here, it's locked on that. Then we do a wait. And I see. So we pass in the condition and the mutex. So we'll kind of release the mutex and then wait for the condition to get signaled. Maybe that can just be called heads data. And here we need to go here and the cond init just did the same thing. Has come on. Let's go here. I just want to go there. I'm trying to do like control N, but my A, when held, is a control, which would do the thing I wanted. But if you kind of like tap it, I don't know, mechanical keyboards, they have issues sometimes, but you just kind of learn to be around them, and talking about them helps me understand what the issues are. Cool. So if we do this, we probably want to signal the condition after we unlock it, do we have to hold right, called with mutex locked. Oh no, that's just for the wait. But the signal is the signal even in this. Oh goodness, it just isn't, is it? Uh, this headed. This man page. So if we signal and stuff, we probably want to do a broadcast actually. Like when we add something, we might add lots of things. Um, do we have to hold the thread? There is no mutex to hold. Easy. So I think we can probably just do pthread on broadcast. So yeah, if we do that broadcast and we can do list not empty. Oh no, here's data. Here's data. And then in this, which I think I want to do something like that. This shows how we're waiting on it. We simply just wait on it. And I think this goodness, have we switched keyboards? Right. So while the list size is 0, we want to do a pthread con wait, and we want to pass in the condition, which is has data, and we also want to pass in the lock with lock on. And potentially we should be checking like errors and whatnot. So if this not equal to 0, we can probably just do yeah, all right, the error the thread mutex block error, do that, and I don't know, it's like, oh no, this is where I just want to do that. But I should not, I should persevere with view, yeah, that's right. User include sys exit. I want something like, so if something failed, then that's probably like a software. It could be, yeah, I don't know. It's a software error. Come have a look for it. Cool. So if that is the case, we can just go ex software, and it should know what the case is. And here we should probably also do this if not equal 0. Yeah, that's also the case. And this, instead of mutex, it's actually con wait. And once we go here, just get those lined up. We should have it And do we lock again after getting it? P thread cond wait, we have the mutex, and then all right, mutex is locked after doing it, so we don't actually have to check whether the mutex exists anymore. I've got an extra thing there, but we also want to pthread mutex unlock and do a list lock. Do something like that. But the job that we are going to return is going to be list data. And at this point here, after this while loop, we know that list size is not equal to 0. And because it's a size tier, that just means it's greater than 0. So that means that we can just use list size. And we can do a minus minus here, which will bring it back down to something potentially 0. So the next time someone calls job next, it will uh, wait. Which key am I? Cool. That's doing it. Job is null there. That is because we don't have a job yet. But we will just return that. Right, so return no value. We probably need to return null to say something happened. So in reality, this should always return something that isn't like potentially this instead of exiting, we can probably just return null, and they'll probably get rid of some warnings because I probably don't have sys exits include. Right, so it, gosh, all right. We don't use data down here. I think we can probably get rid of this stuff. And do we get Pierre's job? I think we don't do. Oh no, we do. So that's the job that we kind of want to call. But I just want to see what things happen. Right, that's all right. Oh, give me an error. It doesn't like that. It wants a void star. I did think it might need a void star. All right, take me there. We don't do that. So what I might do is set there, and we can do this, and this is just going to be a casting of job list from the data, which will be void data. Are you happy now? It's somewhat happy. Right, so maybe I'll do a little print. Cool. Maybe we can probably get a period as well. And we can get his job with there, I guess. And it will maybe do something like that, and also pass in that pair. So what doesn't I like here? We do this void star before here. What's our next one? I still doesn't like that. We're meant to return winter. All right. What should we return? We can just return null. Cool. So that did a thing, did nothing. Which somewhat surprises me. Because I thought it would do a thing. Like, for example, be in here. So they both get the same pointer to jobs, but they do not do this properly. Cool. So I wonder if this is also returning me an int that I should probably check for. Okay, go here. And that's an unlock. Cool. So I guess here I want to say that this is job next critical. We can get rid of that. And the job next is I want to do this and then go here and go here. The critical is like what like academia calls like the critical portion, the thing that you need a lot because it's critical. You don't want it to do that. So I guess here, and this can be unlocked. And this can be unlocking, and it's actually waiting at this point here, waiting for data. So that's kind of a bunch of stuff that I want to say, and I probably want to say it all everywhere else. And this should probably also have do this and like maybe get the job actually that one and what was add because it is adding and what else was I thinking? Yeah, if list data, well, can it be null? It kind of yeah, it can be null. So I think this needs to be void star data. That's safe to do there, and then list data equal to data, if that is the case. And probably here we probably want to test that if this is now something went wrong, which I wonder if we can do something like this and re-alloc array. You know, and maybe something just like return. This can probably just be that. Dot add resizing. So, like, if we do a return early, we really need to go to lock. Right, so I think these two are actually round the wrong way, which kind of makes a thing broad. Let's make this add job add. All right. Unlocked. This is unlocking broad sting. And we call it unlocking in here. Critical end, I think. Critical end. So where did I go? Critical end would be here. Critical end. Now, what else might return errors? So here, that's right. I kind of want the unlock to always happen, even if there is an end. So that's probably at that point there. So even if there is an error further up, but we don't need to do it if we never got the lock. And here, if this, come on, there, not equal to 0, then we do some things. And here we probably also want to do that not equal to 0, do some things, and maybe go here and start those things off. And what are the things? They will be this. And they will be this. Now, this I want to like. Maybe I could do this like. Wow, no. Yeah, actually, no, that's exactly what I wanted. And here I maybe just go here and unlock. Cool. Show me some errors. We don't have P. That is because we have not. Where do we get like a P? I think this P is, well, I put it in too many places. It's not really the best name, but we can call it P. Really, what I should do is, no, I don't know. Right, so this has done some things. There's a warning. too many arguments to format. Jobs is 0x CP. Cool. So here we can see some things. And jobs is null. Good start. But we can see here that we were in job add and we locked. We did a critical, we resized, we broadcast, and the critical ended. So we didn't get logging in this job next. Which I thought we would have. Um, Oh, I see. Yeah, jobs is no. So does that mean we're like we're not passing in? We need to pass in our jobs to that thing. Now this is doing a thing. It did not like that. What if I like just do that? So we add a bunch of stuff. We have an address. Job next. We should probably say whether it returned a thing. It should. It gives us nothing. I just don't understand why it is. We pass in job, and we should bail if doesn't do it. So we should have added a job to the jobs. Thinking about debugging this. It's trickier, but yeah. Right. That needs topping up. So why did it crap out when I did both? So I think that's because this jobs needs to be in shared memory. Is that the understanding I have? Because like, what if we just even look at here? You're already doing that. We don't get P yet. We can just bring P up there. It's just not doing anything. Like, what if we do like a return null there just to make it kind of crap out? So we do have two lists. It's frustrating that it's not even printing a thing. So I guess if we don't add a job, it should just be like waiting. like I don't understand why it's not showing this like initial thing. Maybe if it is. Maybe like, well, actually, what if that happens down here? No. Um, we undo that. So the job ad, well, in fact, we got to unlocked. Yeah, so the job ad just did everything. Not that one. That one. Right, so if I adjusted one, then the job ad worked. In job next, I think I need to say that this is a dying. Which it shouldn't die. It should only die if or yeah, so we're only using one thing. But yeah, it should only die when it gets nothing out of it, which means that job next. Job next is returning null, which it would have gotten out of the list. I think, yes, that's what I want. I want this to be pre-negate. And now just doesn't want to do anything at all. Job add, we get a thing. Now, even with just one job, it hangs on something. I don't know. I really wish that it would print out while it was hanging. Uh, yeah, I don't know. This is kind of annoying because it's um let's see, Codecrafters. It's like a thing that you can't really debug that easily. Layout source break job test. So we can do this, but I guess we can something like this, and maybe if we step into this, and we can probably do a display list. No, we want to do I forgot this. Actually, if we do that, right, so this has got a lot of stuff in it because it's got that lock and it's also got the thing, but the data size and capacity kind of legit. So we can get this. So if we do that, the lock should change from something there to a bunch of ones, I would imagine. So here we can see the lock has some stuff, and like here it's got a bit different stuff, and it's got a lock as one. Right, so we have the lock. Makes sense. We should need to resize. So this data should become a list data. So here we can kind of see what that is. That doesn't really show me what I want. Display. So what if we get a list data? What if we get that as a thing? So this should be the same as job, p job, which is kind of right, but the memory space is different. I suppose that's in like malloc land. Yeah, so that was malloc and this was not malloc. This is just somewhere on the stack, somewhere. So and it has the same number. So here we kind of have a thing that it points to. Right, so here we should broadcast and then we should unlock. So that lock, which is annoyingly display. So 3 is what I don't really want, and also 5. And can we like what do we call it? It was just called list. So now the lock is no longer with us. Right, so it's done that. Now we should do this. Now, can I do a break on a job event loop? And we should hopefully get when this happens, we get a break on this thread. So I think you can go like info threads, yeah, and then that will show all the threads that are kind of running at the time, and everything should be paused at the moment, which is good because I want to know that that's there. So this job's here, display jobs. So that looks about right. And this looks fairly legit. And if we look at the data, that looks somewhat like it was meant to be. That one. Will it let me? Yeah, it will. And so that is the first job of there. So we'll step into this job next because I am wondering why it crashes. So we are locking. We get a lock. This is seemingly working. So we're in the critical, that's cool. List size is fine, but now we should get a ret. So maybe if we display ret looks right, we should unlock, which should then free it up for someone else. And we should come back into here and we should print this thing. And it, yeah, and it did it. And now it's like waiting for more data. But it's I wonder if it's like a busy lock or something. Yeah, there's something going on. But yeah, that definitely seemed to right, and then that seemed to do it. So why doesn't this seem to do it? This is when running in Vim, I guess. It's waiting for the job to finish, which it's kind of not. So if we do this, we should get kind of two jobs. There's E, then a DF, and a DF2. So DFC and DF2. And we should have got a job from there, but we're waiting for data on both of them. So that actually looks cool. It's just annoying that I can't kind of test it in uh, what I can do is kind of have a fake job of no, that's not quite right. Yeah, I guess like after you pull off a job, you should put on a new job, and if you don't, you should probably exit everything. Um, but yeah, so I guess now that we can kind of do things, we have a job, and that has a what do you call it? A funk. And what do we want to call with the funk? Uh, this stuff here I can probably kind of get rid of. No. So what do we? Let me take here. We just want to pass in the job to the fund. It's kind of a weird way of doing it. Potentially, well, I guess like we actually really want to pass in that data, which makes kind of passing in functions a lot easier because then it's just always a void stuff data. The callback, I think I decided I don't need, and it doesn't seem to need it. So get pairs job now is no longer like we actually need a void star data. Um, and that is uh, going to be so this is going to be a job star of data, and we should probably do like some tests. If data equal null, probably just return, and if we can probably test here if here equal null. Actually, we just printed it out, so yeah. But yeah, make sure we don't read that first, and then we can print it out. So after we do this pairs job, I kind of want to. So we pass in the pair. That's right. So this is we're just going straight to this. So we just go straight to passing in the pair. And what do we want to pass in with the pair? Remind me what it has in. It has like a bunch of things. So the get pairs job, we kind of just want to get a like random pair response. I kind of like made it thing. But yeah, if we get a random pair from response, how do we do this other places random? Um, yeah, cool. something like this. Thing that's potentially what I want. What's this length? Yeah, that's all good. So I'll kind of just do this. And as a quick test, we will do something like info hash, and this is going to be uint 8 t, and it's going to be SHA-1 by that thing. And this can probably, we have it in this, we can find there, and that is our hash. Come on. No, that's not quite going to work, is it? I need to like get out of here. Can we still paste it? Cool. We can still paste it. So this needs to be in quotes, but then kind of find that C again. Needs to be something like that. Yeah, that's what we want to add. So we kind of want to, let's do a thing here. Yeah. So let's do a recording macro. Want to do a recording macro. Want to do that over there, and then two over. Let's go here and Q. Right. Adding a macro and then two to that way, and then that's my Q, and then 19 do that again, and that is how you make that digest stream. What I think, just because I realize I've gone like quite some time, I might actually pause that there and try and work out this and come back to it probably with a fresh mind. But yeah, thanks for watching anyway, and I'll see you next time.